Okay, I'm just going to give you guys a little bit of background, some vocabulary when it comes to triangles, and then you guys can take that to the packet. All right, so when it comes to triangles, we have to be able to classify triangles. And there's two different ways to classify triangles. The first way to classify triangles is by their angles. And the options are first, acute triangle. This is a triangle where all the angles are acute. And we know acute means less than 90, so I'm just going to write where all angles are less than 90. The second type of triangle is going to be a right triangle. This is a triangle with one right angle. Only one of them is right. The other ones are going to be acute. And the second one is an obtuse triangle. This is a triangle with one obtuse angle. And lastly, for the angles, we have what we call an equal angular triangle. You guys have heard of equilateral. Equilateral is when, hopefully you remember that, when the sides are all congruent. Equal angular is a triangle with all angles congruent. All right, so let me just do a quick sketch of these. If it's an acute triangle, it'll look something like that. All the angles are less than 90. If it's a right triangle, it will look something like this. Again, only one of the angles is right. It would have to be marked 90 degrees. You cannot assume anything. So you need that box there. If it's obtuse, it's a bad triangle, but it's there. It's not the best triangle, but it's obtuse. Obtuse will look something like that. I can do a little bit. Hold on. A little better. Still not the best, but a little better. If it's obtuse, again, it's going to have one obtuse angle. So that one angle that's more than 90, and then the other two angles would be acute. And then the last one would be equal angular. And again, if it's equal angular, it will be marked as so. So if it's equal angular, it'll look like this, and all of the angles will be marked congruent. Now, just as extra information, which will come up soon, when it's equal angular, all of these angles are going to be 60 degrees. Therefore, it's also considered acute as well, because all of the angles are less than 90. All right, the second way to classify triangles is going to be by their sides. So, by the sides. And when it comes to classifying them by the sides, there are also four options. The first is scalene. This is a triangle with no congruent sides. So all of the sides have different measures. Next, we have isosceles. Actually, there's only three of these. I think I said four. Isosceles is a triangle with at least two congruent sides. All right, so let me just sketch. I should have done it the first time. If it's scalene, it looks something like this. Again, where all the sides have different lengths. If it's isosceles, we're talking about something that looks like this, where it has two congruent sides. Now, if you look at the definition, it says at least two congruent sides. So that means it could have more. So technically it could be 3 sides congruent. But if there are 3 sides congruent, even though it is also considered, I'm sorry, I'm putting extra letters here, equilateral. If it's equilateral, that's the last one. This is a triangle with all sides congruent. All right. And if it's equilateral, it will look like this here, where all of the sides are the same. And again, technically, if it's equilateral, it is considered isosceles, but you would always classify it in the most specific way. So if it had 3 sides congruent, your instinct should be to say it's equilateral, not isosceles, even though technically it's both. All right. And then the last thing we'll talk about that's in our triangle packet today is going to be the triangle angle sum theorem. Actually, there's one more thing after this. I shouldn't have said last time. All right. So the triangle angle sum theorem, most of you already know what this is. I'll just do a few basic examples and here in the video, and then we'll do some examples in the packet together. But when it comes to the triangle angle sum theorem, what that theorem says is that in any triangle, if a figure is a triangle, then the sum of the interior angles is exactly 180 degrees. All right, so the triangle angle sum theorem. So here's my figure to go with this theorem. So here's my triangle ABC. So what this triangle angle sum theorem is saying is that if a figure is a triangle, then the sum of the interior angles is exactly 180 degrees. So not 179, not 181, exactly 180 all the time. And so that would mean here, if you have this diagram, that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. That's the triangle angle sum theorem. So I'll give you guys about, again, like 3 or maybe 4 examples here, but for the most part, we'll do these in the packet. So the simplest application of this would be if this was my triangle. Oh my gosh, this is so wonky today. Example 1. All right. So let me try it a little better than that. It's a little better. For this one, let's say this is 84 degrees. Let's say this is 62, and I ask you for x. This is, again, like, I would say this is a middle school, 4th grade, maybe like, maybe middle school application of the triangle angle sum theorem. So it's not really too difficult, but we'll go through the process, and then we'll get to something that's more on the level that you should expect. So you'll see something like this, and it'll be x plus 62. Now, do you have to set up an equation for this level of a problem? No, I wouldn't expect this or require this as far as for work, but I do just want to go through the process so you guys would know what to do. So we do 62 plus 84. That's going to be 146. Equals 180. And then I would subtract the 146. And I get x equals 34 degrees. Example 2. Example 2 would be something like this. All right, now this would be more on the level of like a geometry problem. So this would be like, let's say 54 degrees. So this is 48 degrees. X, Y, 62, and Z. Now this would be more of a geometry level problem with this triangle angle sum theorem. And for this type of problem, what you would have to do is solve. We need x, we need y, and we need z. What I would suggest you would do for this particular problem is to kind of like block it out. I would pretty much like ignore this part of it for now and just focus on this triangle first. So if I focus on this small triangle, again, just totally ignore the other side, I'm doing x plus 48 plus 54 equals 180. So x equals 48 plus 54. It's going to be 102. Oops, that maybe equals x plus 102 equals 180. And I end up with x equals 78 degrees. So that means that this is 78 degrees here for x. Now, what you should know about geometry at this point is that vertical angles are congruent. So since vertical angles are congruent, now I'm going to erase these extra. Oh, I thought they would just go away easy. Darn it. Whatever. Hopefully you can still see enough of it to understand. But anyway, so now I still need to find y, I need to find z. So for this, y is also going to be 78. And again, hopefully that's kind of obvious because remember vertical angles are congruent. So that's how I know y is 78. Then I can find z by doing 62 plus 78 plus z equals 180. Because I know that this triangle in the purple circle is also 180. So add these together, I end up with 140 plus z equals 180. Z is 40. So that would be more of like a geometry application of this triangle angle sum. And we'll just do one more example, and then we'll just come back together and work on the packets. And then example 3. So for example 3, let's just throw some variables in here. So let's say this is 6x. This is 5x plus 10. And this is 3x. Now, a problem like this, and let's say this is A, B, and C. And I'll ask you for the measure of angle A. In order to do this problem, again, you would start it off the same way with the angle addition. Triangle angle sum, not angle addition. And triangle angle sum says that angle A plus angle B plus angle C is 180. So that's what I'm going to do. 5x plus 10 plus 6x plus 3x equals 180. Add that all up. That's 9, 14x plus 10 equals 180. 14x equals 170. 170 divided by 14. I get x equals 12.1. I'm rounding to the nearest tenth. Then I would have to find the measure of angle A. So the measure of angle A, I would substitute 5 times 12.1 plus 10. So that's going to be 60.5 plus 10. So That's it. All right, so we'll pause this. So we'll stop this now and we'll come back together and work on the packet.